points. Okay. Remember, which asymptote are you allowed to cross? The horizontal one. You can cross an in behavior asymptote. You cannot cross a vertical asymptote because the in behavior or horizontal one just describes what the ends of your graph are doing. So unlike vertical asymptotes, which can never be crossed, vertical asymptotes can never be crossed. A rational function can cross the horizontal asymptote. It's allowed to. A rational function can cross the horizontal asymptote. It can also cross a slanted asymptote. Horizontal asymptotes just describe the end behavior of the function as it goes to infinity and negative infinity. Here's the important part. To find if and what point the graph crosses the horizontal asymptote or the end behavior asymptote, you're going to take that horizontal asymptote, you're going to set it equal to the function and solve. Okay. So there's always two possibilities whenever you solve, because basically you'll be solving a little equation. So say you solve the equation and you get something that says like 2x plus 5 equals 2x plus 7. Okay, so say this is your little equation you're solving it. What would be the answer to this little equation? It would mean, yeah, it would say 0x, which do we even need to write 0x? No. So then it would say just 5 equals 7. What would be the answer to that? That's not right, right? What would we write for this? You would write no solution, right? So if you're solving to find the point that it crosses the HA and you get no solution, guess what? It doesn't cross, yeah. If you get no solution, that would tell you it does not cross the HA. Doesn't cross the HA. Okay. But if you're solving your little equation, you set it up and you get something like 2x plus 1 equals 3x minus 5, this one would have a solution. Okay, so on this one, because it would have a solution, you would get, what, 6 equals x? So that means it would cross at 6. So if you get an answer, that's where it crosses at. If you get a no solution, it doesn't cross. Crosses at x equals 6. So those are going to be the two possibilities. Whenever you set up your problem to see if it crosses that horizontal or in behavior asymptote, you either get no solution, which means it doesn't cross, or you get an actual answer, which tells you where it crosses. So for the first one, we're going to find all the key features of the rational function and determine if it crosses the horizontal asymptote. First thing I want to do is what? Solve it, simplify it, factor it. We want to factor it. Good. All right. No, it is not the same thing. Okay. For factoring, let's see. For the top, we're going to need two numbers that multiply to 30, but they add to negative 13. Negative 15 and 2. Those don't multiply to 30.
Oh, negative 10.
Negative 10, negative 3. Negative 10, negative 3. Do those multiply to 30?
Yeah.
Do they add to negative 13?
Yeah.
Okay, so we're going to split our middle term with those. Minus 3x plus 15. We're going to group. What is the GCF of that first group? 2x. Good. And then if we divide both by 2x, we're left with x minus 5. Good. What's the GCF of the back group?
3.
Negative 3. And if we divide both by negative 3, we're left with... Perfect. Okay, so these are my top factors. I'm going to have x minus 5 and 2x minus 3. The bottom is easy factoring. We're just looking for two numbers that multiply to negative 12, but they need to add to negative 4. What are those numbers? 6 and negative 2. Negative 6, positive 2. Yes, that is right. Negative 6, positive 2. All right, excellent. Looking through that, can I cancel any? No, bummer. I want to cancel because then it makes them easier, but it doesn't. What does that tell me about my graph? There's no holes. Okay, next up, vertical asymptote. How do I find that again? That's where your denominator equals 0. If I have 2 factors in my denominator, what does that tell me about my vertical asymptotes? There's 2. 1 when x minus 6 equals 0, 1 when x plus 2 equals 0. So the first one is at 6, the other is at -2. That sounds like it's going to be fun to graph. The horizontal / end behavior asymptote. Remember, for this we're looking for the degree. What is the degree of the top and the degree of the bottom? They're the same. What do we do when they are the same? A over C. Very good. If exponents are the same, you do the ratio of your leading coefficients, A over C. So that would be y equals 2 over 1, which is just 2. Okay, and now that we know that it is possible to cross a horizontal asymptote, that's what we need to figure out. We need to say, does it cross it? So I'm going to come down to the bottom and just check to see if it crosses my HA. Okay, so what I'm going to do is I'm going to take my horizontal asymptote number, which was 2, and I'm going to set it equal to the function 2x squared minus 13x plus 15. X squared minus 4x minus 12. How would I solve this? Yep, multiply by the denominator. Does that cancel the denominator on both sides? Not on both sides, not on this one, because we don't have a 0. But it does cancel on the right. So let's see, on the right I'll be left with just what the numerator was, plus 15. On the left side I can go ahead and distribute. 2 times x squared would be 2x squared. 2 times -4x would be -8x. 2 times -12 would be -24. What's going to happen to those 2x squareds? They're going to cancel because you're going to subtract. They're going to both cancel. So is this still a quadratic? No. It's a little linear function. It's a linear function that has variables on both sides. So I'm going to cancel them off of one side. -8x plus 13x. 5x. 5x minus 24 equals 15. If I add 24 to both sides, I get 5x equals 39. Good. And then if you divide by 5, you get x equals 39 over 5, which is, what is that as a decimal? 7.8. Yeah. So it does cross. It crosses when x is 7.8. So does it cross? Yes. 7.8 comma, what is the y value of where it crosses? 2, because it crosses at the horizontal asymptote, which has a y of 2. Okay, so it is going to cross our horizontal asymptote at 7.82, which is basically a point we can use later, so that'll be nice. What else do I need to find? X-intercepts, y-intercepts. The x-intercepts, remember, that's when y is 0. But do remember, when y is 0, that means your denominator is going to cancel. So you really just have your y equals 0 set equal to your numerator. So I'll have 0 equals x minus 5 times 2x minus 3. How many x-intercepts will I have then? 2. Yeah. 1 when x minus 5 is 0. 1 when 2x minus 3 is 0. So one's at 5. What's the other one at? Plus 3 divided by 2. Very good. Okay. Remember, these should be written as points, so I'm going to have 1 at 5, 0. 1 at 3 halves, which is basically just 1.50. We're going to have plenty of points to graph on this, which is good because we are going to, if you have 2 vertical asymptotes, you're going to have 3 branches. All right, and then lastly, the y-intercept, remember that's when x equals 0. Which of these would it be easier to plug in x equals 0 to? Not the factored one. It is super easy to plug it in to the one that's unfactored. Because basically everywhere there's an x, it's going to turn into 0. So I usually just take my finger and cover them up because it's 0. And now I just have 15 over negative 12. Look how easy that was. If all of these are 0, they don't exist. And you just have 15 over negative 12. So we would have, let's see, 15 over negative 12, which does reduce to what? Yep, negative 5/4. Which, as a decimal, where is negative 5/4? Negative 1.25, right. All right, we have a lot of information we can put on our graph, which is, again, going to help because if you have 2 vertical asymptotes, you got 3 branches. Yes. No. It's important. It's important. Maybe after we finish the graph. Okay. I'm going to start by doing my vertical asymptotes. I got 1 at 6 and 1 at negative 2. 1 vertical asymptote at 6. 1, 2, 3, 4, 5, 6. 1 vertical asymptote at negative 2. Okay, I have a horizontal or end behavior asymptote at y equals 2. Okay, and then I have 1, 2, 3, 4 points I can graph. Tell me how I have 4 points I can graph. Y-intercept, x-intercepts, and the crossing point, the point where it crossed this asymptote here. Okay, so I'm going to have, let's see, an x-intercept at 5, 0. 1, 2, 3, 4, 5, 0. Another x-intercept at 1.5, 0. A y-intercept at 0, negative 1 1/4. And I cross the horizontal asymptote at 7.82. 1, 2, 3, 4, 5, 6, 7, almost 8, 2. Okay. So if we have 3 branches, which branch do I have enough information to graph? I do have enough information to graph the middle one. The middle one's going to kind of look like an upside down U. I know it's not going to be a snake on this one because I don't cross the horizontal asymptote anywhere else than right here. If it was going to cross anywhere else, we would have found that number when we solved our little equation. So I have enough information to kind of graph this middle one, making a little weird U shape. It's not going to be a beautiful U, but it's going to be a little U-y. Is it U-y or U-ish? U-ish? We are going to have to find a point on the left asymptote, or not the left asymptote, the left branch. Extra point. Okay. What x would y'all like to plug in? Negative 3? Sounds great. Let's see. I'm going to plug it into the factor one. Negative 3 take away 5 would be negative 8. And then I have, let me see, 2 times negative 3 would be negative 6, minus another 3 would be negative 9. On the bottom, negative 3 minus 6 would be negative 9. Negative 3 plus 2 would be negative 1. Technically, you could cancel those negative 9s out, so it's just really just negative 8 divided by negative 1, which is 8. So negative 3, 8 is on my function. 1, 2, 3, 4, 5, 6, 7, 8. Do I have enough information to graph this one? Yes. Okay. Am I going to cross the horizontal asymptote on this side? No, we would have found that point if so when we were solving our little equation. So it's going to stay within the asymptotes. And then I have one small issue on the right-hand branch. I know it crosses here, but I don't know if it comes from the bottom up and crosses, or if it comes from the top, crosses, and then hovers around the asymptote. So what are we going to need to find? Yeah, we basically need to find the point that's at 7 and figure out when it's at 7, is it coming from the top or is it coming from the bottom? So I'm going to plug in 7. Let me see, that would be 7 minus 5, which is 2. 14 minus 3, which is 11. Right? 7 times 14, yeah. On the bottom we'll have 7 minus 6, which is a 1, and 7 plus 2, which is a 9. 22 over 9, which is,
It's like 2.44.
yeah, approximately 2 point something. We'll go with 4, whatever. So that tells me, does it come from the top and cross or does it come from the bottom and cross?
74.
Why do you keep saying 74? It comes from the top. Alright, so when we're at 7, we're at 12.4. So it's going to come from the top. It's going to cross the horizontal asymptote. Now let's think about when it crosses. Does it keep going down? No. It doesn't keep going down because your horizontal asymptote describes its end behavior. So as it goes towards the right, it needs to stick close to your horizontal asymptote because that is still its end behavior asymptote. Sean. Okay. That was beautiful. Was y'all's as pretty as mine? No? Yeah, it's the graph part that's annoying. I agree. What are we going to start by doing? Factoring. Does the top factor? No, the bottom or the top's linear, so it's not going to factor. On the bottom, that's just a tiny little bit of factoring. What factors on the bottom? Yeah. X times x minus 3. Good. Okay, does any of those factors cancel? Does this x cancel with this x? No, because this one's trapped with that. Technically, it's trapped with the subtraction. I know, thank you. Are there any holes then? Nope, not on this one. What a bummer. Vertical asymptotes. How many are there going to be? 2, because there's 2 factors in the denominator. So one's going to be at x equals 0. One's going to be when x minus 3 equals 0. So one at 0, one at 3. Asymptotes. We got to look at the degree for the horizontal asymptote / end behavior asymptote. Smaller on the top is not part of my acronym. Bobo, bigger on bottom. Yeah. Bigger on bottom, it's at 0. Bobo. Bigger on bottom, 0. Yep. But then what do we need to find now? If it crosses. I'm going to go down here. I'm going to figure out, does it cross that HA? Okay, so how do we do that again? Yeah, you basically set your whole entire equation equal to the number that you just found for the horizontal asymptote. So we're going to say 0 equals x minus 4 over x squared minus 3x. How am I going to solve this? Good job, it is, yes. Because when you multiply by your denominator, it's going to feel very familiar. This is basically how we find the x-intercept. We plug in 0 for y. Good job, Paul. Denominator is going to cancel. On the left, it's just we have 0 equals x minus 4. And remember, this is how we basically find the x-intercept. So it does cross when x is 4. Comma, and then remember your second number is basically what the HA was, which was 0 on this one. That's kind of a bummer when it crosses at the x-intercept because that means I have one fewer point that I could use to graph with. Because now I already know what my x-intercept is. What's my x-intercept? 4, 0. Just found it. y-intercept. Yep, think about the y-intercept. You're plugging in x equals 0. We'll have 0 minus 4 over 0 squared minus 3 times 0, which is negative 4 over 0, which I heard someone say is what? It's not 0. It's, Mason, it's undefined. You can't divide by 0. If it's undefined, what do I say then? If I say, where is the y-intercept? There's not one. Yeah. None. No, it does not cross at 0, 0. There is not a y-intercept. Okay. Which means we don't have a whole lot of points that we can use to graph, so we're going to be finding a lot of extra points. Yeah. What a bummer. I'm going to graph my two vertical asymptotes, which remember you're never allowed to cross these. Okay, I'm going to cross my, draw my horizontal asymptote, which was at 0. Okay, and I'm going to plot the one point I have. I know that it crosses the HA at 4, 0. 1, 2, 3, 4, 0. Okay, so extra point time. We're going to have a branch in the middle, we're going to have a branch on the left of 0, and we're going to have a branch on the right. Do I have enough info to graph any of them yet? No. What y'all want to plug in? Negative 5? You already did that one? Was it nice? Oh, Gary, just telling me random numbers to plug in. Negative 6? Why are we picking such weird numbers? Like, I like to stick close to the asymptote. Yeah, like negative 1, negative 2. I'm going to do negative 2. Alright, so on the top I'm going to have negative 2 minus 4. On the bottom I'm going to have negative 2 actually I'll just do negative 2 times negative 2 minus 3, which is negative 5. So that's negative 6 over 10. So negative 3/5. So a point at negative 2, negative 3/5, negative 2. Is that what y'all got? Yes? No? Anyone concur? Or no one else did it? Okay, thank you. Thank you. All right. Negative 2, negative 3/5 is like down 0.6. Do I have enough information to graph this branch? Yes, because I know it's not going to cross the HA anywhere else, or we would have found it. So I know this branch is going to be down here in quadrant 3. Okay, I got to find a point in the middle of my two vertical asymptotes to figure out where my branch is. 1 sounds great. Okay. So on the top, we'll have 1 minus 4, which is negative 3. On the bottom, we'll have 1 times 1 minus 3, which is negative 2. So that's negative 3 over negative 2, which is 1.5, yeah. So at 1, we're at 1.5. Do I have enough information to graph that branch? I do. I do. What's it going to look like? Like a U, yeah. Because I know it's not going to cross this horizontal asymptote again, or else I would have found it. And that's the only shape that we make in between two vertical asymptotes. It's either going to be a U that looks like this, or a U that's upside down down here. So draw a skinny little U. Skinny little U. Good enough.
What about the crossing over?
Right here? This is where it crossed.
Oh.
4, 0. Okay. And then on the right-hand side of 3. Now again, I don't know. Did it come from the bottom cross and it stays above? Did it come from the top cross and it stays below? We don't have to plug in a decimal right here. We can plug in a number after this just to see is it above that or below that. Wait till we're done. 5 sounds great. All right, on the top we'll have 5 minus 4, which is 1. On the bottom we'll have a 5 times 5 minus 3, which is a 2. So we're at 1/10. So that does tell me at least it stays above. So if I'm at 5, 1, 2, 3, 4, 5, 1/10, where does that tell me it came from then? The bottom. It comes from the bottom, it crosses, and then it's just going to hover across that end behavior asymptote. Don't put your notes away yet. We're going to talk about one more thing in the empty space on the bottom. Okay. Ready for some thought-provoking? Earlier I said, again, yes, you can cross an end behavior slanted asymptote. And I mentioned, can we cross, or I did say this already, we can cross a slanted asymptote. Everybody heard me say that right? Yes, you can cross a slanted asymptote. You can cross a slanted asymptote. Okay. Now, what do slanted asymptotes look like again? What does it look like? A linear equation, yeah. All right, y'all tell me a linear equation. Y equals 2x plus 4. Sounds great. Okay. So if you found out it crosses here at this slanted asymptote, or sorry, if you found out this is your slanted asymptote, how would you find where it crosses that slanted asymptote? What would you need to do? You would need to take this and do what with it? You would need to set it equal to the rest of your function. Set equal to your function. And then you would solve it for x. So just figure out if you get a solution or not. So say we got a solution. Say we did this. We did all this math and we got a solution of yes, it crosses at 3/4. How would we find the y value of where it crosses? Plug it. I see a lot of people when they do this, they'll write 3/4 and then right here they'll write 2x plus 4. That's not a y value. How would I find the y value? What do you mean by solve it? Plug it into the linear equation, right? To find this y value, you would have to take whatever x you found and you would have to plug it into your linear function. So you'd have to do 2 times 3/4 plus 4, which is 6/4 plus 4, which is 4 plus 1.5, which is 5.5. So again, it's like whenever you take this and set it equal to your function and find the x, to find the y then you would have to take this 3/4 and plug it into your little linear function. Just in case that ever happens, now you know how to do it so that you don't write 2x plus 4. All right.